Yeah. Okay.
Go ahead, Steve. You had something to.
Or should we wait for?
Can you hear me, guys?
Yeah, we hear you. Can you hear us?
Cool. Yeah.
Yeah, and I'm not sure it's being recorded. It doesn't.
I see the recording signal up in the upper left.
Yeah. Should be all right.
And then we're just barely reached 8 o'clock, so I think we should wait another couple minutes before we have the presentation start.
Yeah.
Hi guys, I'm Sarath. I'm a principal engineer in the platform engineering group at Rafay. Today I'm going to go over. Today I'm going to give an overview of our Edge platform, along with some of the customizations we have done to Kubernetes. So that it suits our needs at the edge.
So first of all, can everyone hear okay?
Yep.
Great.
Everything is good.
Yes.
So at a very high level, the platform consists of a core, edges, and DNS. The platform consists of a core, edges, and DNS. The core is responsible for federating the edges. The edges are geographically distributed, and location-aware DNS sends traffic to the nearest edge. And we have placement policies that decide how a workload should be placed on edges. Talking about core, so the Rafay core is the brain of the system. It coordinates operations across all the edges, making them act as one cohesive unit. It provides a multi-tenant view of all platform primitives like container registry, workload, ingress, key management, etc. All the edges continuously report events, logs, and metrics back to the core, where they are aggregated and appropriate actions are taken. It is also responsible for dynamic orchestration of workloads across Rafay edges. The lifecycle of an edge is also managed by Rafay core. Going to the Rafay edges, they are off-the-shelf Kubernetes clusters. They are independent. They're independent and self-contained. So no two edges share state between them. They have customizations like Kubernetes CRDs, replicated storage, key management, debug tools tagged on top of them to make them better integrate into the Rafay Edge platform.
And do you want to pause and ask for questions as we go along?
Sure, yeah.
So happy to take questions as we go. I see there's something in the chat. Let's see. It's a small enough group. If anyone has questions, go ahead and feel free to ask as we go. I'll pause at the end of each slide.
Okay, thanks.
Yeah, thanks. Okay. Otherwise, we'll move along. This one's busy.
Yeah. So we'll look at the edge, the architecture of an edge at Rafay. We have three or more nodes. So the first three nodes. The first three nodes are hyperconverged. What we mean by hyperconverged is we have HCD, Cube Master, kube controllers and kube API servers all running on the same node, and we run 3 copies of them for availability. We have cluster that powers our replicated storage, also running on these 3 nodes. All the Rafay control services run in a separate namespace on these 3 nodes. So these 3 nodes can also accommodate workloads. Can also accommodate workloads. When we want to scale an edge, we can keep adding worker nodes, leaving the hyperconverged nodes as is. We don't directly expose a Kubernetes view to our users. So multi-tenancy is achieved using namespaces, resource quotas, and network isolation. Do you guys have any questions about the?
So even though you're showing namespace 1 on node 1 and namespace 2 on node 2, the namespace is a Kubernetes namespace that spans all the nodes.
Yes.
Okay.
Yes. Yeah. Yeah.
And it just so happens that tenant 1 has workloads on node 1, so the ones are not.
Right, but you're not isolating tenant workloads per node in any particular way.
They are, so the networking is isolated. So no two namespace. So in no two customer namespaces can talk between themselves. They can talk within a namespace, but they can talk across namespaces.
Right, but you're not trying to do you're not setting any expectation of physical isolation. No,
we're not. No, we're not. We have additional policies where we can make all the containers in a workload run on the same node for performance reasons. But as is, we don't do anything. They are free to be scheduled anywhere.
And for those of you with really good eyesight, looking at node 1 where it says tenant 2, workload 2, that's really tenant 1 within tenant 1's namespace, workload 2. So there are multiple workloads of tenant 1 in node 1. I just thought that there's a typo in this diagram. Good questions, though. Thank you very much. Anything else on this, or should I go forward?
The crypto edge, can you say something a little bit more about that? This is responsible for registering edge with the core, or?
I have a slide about that, but
okay, great.
But crypto edge enables our key management solution in the edge. So we have a fully multi-tenant key management solution in the edge. All the customer private data like keys and secrets, they all come encrypted to the edge using the organization keys, and they are decrypted and put in the memory when they are needed.
And so, since I see you have console, are you using HashiCorp Vault for that, or you have a? No, on the edge we don't run Vault, but we have a more modified version of Vault running in the core, which talks to our HSMs.
Now, I'm just curious, what makes this uniquely suited for edge? Like, how is this different from just federated Kubernetes clusters in general?
One distinction from KubeFed, as I understand it, this is Jad, is that KubeFed broadly places workloads into all locations, and so we're trying to provide a little additional control over that. And the multi-tenant aspect of the file system view is another aspect. And we're trying to abstract away some of the challenges of configuration management. So providing a higher level interface to the edge.
And then I see it says hyper-converged. Does that mean that you're bundling software plus a hardware solution in your offering?
No. We run off-the-shelf software and this off-the-shelf Kubernetes, but they have our customization stacked on top of them for the edge to be able to talk to the core.
So this is made for just strictly pure commodity hardware, not anything your organization supplies. Okay, got it.
Yes.
Yeah, and by hyper-converged, what I think we mean is the cluster control runs on here, Kubernetes services, etcd, cluster, and so on, and customer workloads. The other way to run the cluster is you have the control nodes and workers. If you have hundreds of workers, the overhead of dedicated control is fine, but this allows us to converge control and customer namespaces onto fewer machines in an edge location. And
okay, I got it. It's just the reason I asked is that there are some industry groups and analysts that use this definition of hyper-converged, meaning people who have products that often bundle not just hardware, but a virtualization solution and kind of a whole stack from top to bottom as a product. So I was a little confused.
Thanks, Stephen. I didn't realize that. So maybe we can adjust that. Well, is there a different phrasing you would recommend?
I can't think of it at the moment, but yeah, if you just Google for hyper-converged, I predict that you'd discover you'd find a lot of these things out there that are kind of completely different beasts from what this is.
Okay. Great feedback. Thank you.
Yeah, this is Robbie from Rafay. May I jump in to explain the terminology? I think what we meant by hyperconverged at the sense was the roles for hyperconverged for these nodes. They're running the master control software for Kubernetes, plus they're running the storage backend, and what they're running is the workers as well. So the roles of Kubernetes nodes in our mind were hyperconverged for these particular nodes.
Great, thanks, Rafi.
Okay, we can go to the next slide.
All right. Whoops, wrong way.
Yeah, so most of the customizations done to Kubernetes cluster on the edge are done as CRDs. Rafay has its own platform primitives that are exposed to end user. They are decomposed. They may be decomposed into one or more Kubernetes objects. Having CRDs allow us easy conversion between Rafay primitives and Kubernetes objects. CRDs also allow schema evolution for Rafay primitives, and it decouples the underlying implementation. They provide a nice framework for handling objects and their life cycles in Kubernetes. So some of the CRDs we have written.
So we'll go into each.
Yeah. So
were most of these things that existed that you then later wrapped in CRDs, or were they kind of built with CRDs in mind?
I'm sorry, can you repeat the question?
Like, were these primitives like APIs and constructs you had in a pre-existing platform that you then kind of wrapped into CRDs, or were these?
No. I mean, no, we didn't have a pre-existing platform, but we didn't want to expose Kubernetes to the end users directly. I mean, we wanted to expose an edge computing platform, not a federated Kubernetes cluster, because then we would be really tied to the actual Kubernetes versions and implementations, right? It is
okay. Yeah. So these are just sort of modified or additional abstractions that you want.
Yes. These are additional abstractions on top of Kubernetes. So workload. So the main CRD for us is the workload CRD. So workload is a very loaded term at Rafay. It is the fundamental. It is the fundamental unit of work. It contains all the. It's like a mix of deployment services, ingress, isolation, resource quotas, everything, and placement. So everything we expose to the user, the unit we expose to the user is a workload. Is the workload, and the workload is decomposed into Kubernetes objects at the edge. The workload controller is responsible for the lifecycle of the workload, and every time we publish or upgrade a workload in the core, so the metadata is captured as the workload spec, and it is synced to all the designated edges, and the status is aggregated back in the core, and the status of the workload is aggregated back in the core for traffic steering decisions.
And have you, how would this compare to the application CRD that's a relatively new standard CRD type for similar sort of scoping? Is it just because that was probably not around when you guys first created this? It seems somewhat similar.
Yeah, we had our own requirements that I mean, so first of all, it was not available at the time we started. And we had our own unique requirements that made sense for us to write our own CRDs, because at the end of the day, the only thing constant is whatever Kubernetes is exposing. So we have to find a way to transform between what our users see and what Kubernetes sees.
Gotcha. Okay, great.
Yeah.
Thanks, Preston.
Yeah. So yeah.
Next
one. Yeah. So another CRD we have written is the workload ingress. So none of the existing ingress solutions support our ingress needs. We built a custom ingress solution clubbing L4 and L7 proxies. The workload ingress CRD represents Rafay view of an ingress in the edge. We currently support TLS with SNI, and as SNI is used for load balancing across multiple workloads in an edge. So SNI is how we achieve multi-tenancy, north-south multi-tenancy at an edge. And,
so you were saying that no current ingress supports your current needs. What are your needs? I mean,
no, I mean, so
somebody connects via the public cloud and can get to any.
So first of all, we are not running on public clouds.
Not just on.
Yeah, so we run mostly on bare metal servers. So the main competing ingress solutions at the time we started were Istio and Nginx Ingress. Istio didn't have multi-SNI support back then. They've recently added it. Nginx supported multi-SNI, but it had its own problems that prevented us from using it. So we built our own Ingress solution. Also, we were looking at other layer 7 features like routing and TLS termination and API key validation, which were you have to customize in Linux anyway to provide like API key validation and rate limiting, etc. on a per SNI basis. So we had to write our own Ingress controller. Are there any questions on Ingress? Okay, yeah. So another CRT we have written is the dynamic config. So Kubernetes has a 1 MB limit for config maps and secrets. So we have written this primarily to address that issue. So
by address the issue, you mean you think you need to go over 1 meg?
Yes.
Yeah. So using the dynamic config, we can potentially send like gigabytes of config data to the edge. So we only send the metadata. I mean, we only send the metadata to the edge as a dynamic config CRD spec.
What is an example of a thing that needs gigabytes of configuration? Like I think of configuration as like just the settings and that kind of thing, and you can point to blobs or you can point to large objects elsewhere. But what is an example of a very large config?
Well, somebody can run varnish cache at the edge, and they have a pre-built cache that they want to bring it to the edge.
In this case, the term config, like a text config file, may be too restrictive because we're using this to include other data that applications may need. Configuration files are one example, and were the motivating example for getting dynamic configuration uploaded into apps without app restarts. And then,
so this is sort of content distribution as much as it is configuration.
Yeah.
And then where are these held? Are these held in the etcd servers running out at the leaf nodes or somewhere else?
Held in etcd?
No. Only the metadata is held in etcd. The actual data is placed in a volume that is mount to the pods that wants access to this configuration.
A Gluster FS volume. All of the edges have a Gluster FS cluster configured in them.
Yeah. So another minor problem we have noticed with config propagation. I mean, when you mount a config map or a secret to a volume and change the config map or secret at runtime, the propagation takes up to 30 seconds. Which is fine, but what happens after so to propagate it, so the old file is deleted, and I mean the old symlink is deleted and the new symlink is created. So if you're using FS Notify or something to watch for events, it's not going to. I mean, so the only event you're going to get is the file is removed. So we do in-place update of the config, keeping the same FD.
I'm curious, are there other, I mean, this is sort of CDN-like in some ways, but it's not really CDN because it might be in the service of an application that's running on the edge, like you say, cache content, et cetera. Have you come across other folks that have looked at how they are, distributing content either for like game servers or other places where you have that kind of need to mirror cache content or assets like that? I mean, I think I understand the use, like the need pretty well, but I'm curious if you've seen other approaches to that in Kubernetes.
If you have an example of other ways that Kubernetes has done this, that would be great. We're looking for use cases and customer applications. We think that placing state in this way can help with some. We haven't.
Yeah, it strikes me it doesn't matter whether Kubernetes has done it or whether something else has done it. I mean, you don't have to use the Kubernetes hammer to do everything you need to.
True.
Yeah.
Well, another example of something that would need this kind of thing is if you wanted to do staged firmware updates. So if you had a bunch of devices on the edge and you wanted to push firmware update that is cached and then redistributed from that edge to each device, you'd want something potentially kind of like this, right?
Yeah, not just firmware, but it strikes me that container image distribution is also potentially distribution of fairly bulky items that are largely read-only once they get to a using destination. I don't know if this is perceived as read-only or read-write once it gets to a leaf node.
Read-only.
It is read-only. It is read-only.
Yeah. So that's a great point.
Yeah, it is read-only. Like config maps or secrets mounted as volumes, it is read-only. It mirrors the same functionality, but it just eliminates the 1 MB limit.
Great.
Yeah.
All right.
So another CRD we have written is traffic shaping. So we wrote this to enable resource quotas for network bandwidth. Combined with Kubernetes network isolation, this enables us to support network level multi-tenancy in an edge. We can shape north-south and east-west traffic in an edge. This prevents from any one single workload monopolizing network bandwidth. And this is also responsible for periodically, so the controller is responsible for periodically reporting bandwidth statistics to the core.
Does your
Yeah. Sorry?
Yep.
Yeah.
Oh, sorry, Stephen. I think you're on mute.
does your use of network attached storage also enter into this traffic shaping? Does it have its own bandwidth carved out?
So right now we are not considering the bandwidth for storage, but it is in our roadmap to include the IO for storage too.
And so I have a couple questions here, maybe really quick. So you're able to provide a single throttling point across workloads across the cluster by flowing all traffic through the controller on the say like the northbound side?
So the traffic entering the cluster is already there are only specific entry points you can enter. So they have to enter to our L7 proxy. So that's where we control the north-south traffic.
Well, but for like egress, right? If you have workloads running on the edge that are reaching others, just say public internet services or set, and you want to limit their how much in the typical sort of asymmetric setting where they're you want to limit how much egress there is from the location because it's limited. Like I've been looking at the details per node and what Kubernetes provides as far as traffic shaping in the CNI, but it's limited per node. There isn't a cluster-wide notion, but you have a cluster-wide notion of total traffic.
So it's not real. So it's not. So the cluster wide is a side effect. So we still set these limits at a pod level.
Okay.
But they get a namespace quota. So which is cluster wide.
Okay. And then are you using the bandwidth plugin in the?
I mean, so we have looked at the bandwidth plugin, but this is in-house. This is based on this is how the bandwidth plugin works internally.
Mm-hmm.
I mean, it's TC.
It's still TC. Yeah.
It's based on TC, but we have written it ourselves. Inspired. It is definitely inspired by the bandwidth plugin.
Okay, great.
So some of the other customizations we have done at the edges, so one of the other customization is key management. So sensitive customer data like private keys are sent and encrypted to the edge with organization specific encryption keys. They are decrypted and stored in memory at the edge for other resources to access them. So this is fully multi-tenant at the edge. So this is the crypto client. This is the crypto edge we were showing in the slide one of the earlier slides. We can talk more about this.
I have a quick question. So since I joined late, maybe you talked already. I'm just curious, what kind of customer scenario led you to support multi-tenancy at edge, and how it's different from the cloud? Because currently for the Kubernetes, there's a multi-tenancy SIG talking about supporting multi-tenancy. So from your implementation perspective, what special you're doing differently from them?
So current Kubernetes multi-tenancy revolves around namespaces, and namespaces, service accounts, namespaces and service accounts, essentially.
Yes.
So we for us, so we need some additional things to be done to achieve multi-tenancy. So we need resource quotas. So CPU, memory, and storage resource quotas are already available in Kubernetes. We have but bandwidth is not available. So we added bandwidth. We added bandwidth, and network isolation is, if you choose Flannel as your CNI, you can enable network isolation between namespaces. So that is also really important for multi-tenancy at an edge, and you need storage. You need multi-tenant storage, and you need to set limits on the storage and IOPS. So I think you can set limits on the storage in Kubernetes by default, but you can set limits on the IOPS. So we are kind of working on that, but it's not ready yet. So the key management is the only place you can put sensitive data in Kubernetes is secrets currently. But we have other components in the system, like our Ingress controller, which has the TLS certain keys. So we can't send the key in plain text, or like we can't just use the system key to encrypt a customer private key to send it to the edge. So we use organization specific keys in the core, and send the encrypted data to the edge. The edge looks at the workload spec and determines what scope the workload is in. I mean, which organization the workload belongs to, and then it goes and talks to our core to get a organization specific cake. And then it is decrypted and stored in memory in our Ingress controller. Similarly, we have API. We have API keys that can also be encrypted in the same way. And if the customer wants to send any sensitive data, any sensitive data that they expect to be mounted as secrets, that they expect to have secrets out of, we do the same thing for them too.
We also introduce key hierarchies. So where organization root level keys are never sort of distributed or used on the edge. They remain, the root of trust remains in core. And the specific use case keys like encryption keys, signing keys, integrity check keys, those are essentially transported over on demand to the required edge for that particular tenant, for that request, for its purpose, and then gets utilized in memory, and then it's retired. So there's sophistication in the use case and also the hierarchy that we enable via our key management agents.
My understanding, the work controller, normally Kubernetes controller use the service account. If I understand correctly, what you're saying is the service account will depend on the organization, pick the right organization cert, and then authenticate or authorize all the traffic, or even encrypt and decrypt. Is that what I heard?
No, I mean, so we don't expose a Kubernetes view to our end users. So service accounts never come into play. So
Okay.
Service accounts are only controlled by us. The customers, the customer containers run at a very low privileged. So they don't have any access in the cluster, except to talk to each other and send and receive traffic from outside.
Okay, thank you.
And I guess that's one thing that maybe is becoming clear over time, is that your users don't know Kubernetes is in the implementation. Like Kubernetes is strictly an implementation detail to your product.
Yes.
Okay.
Yes. Another customization we have done in Kubernetes at the edge is a debug solution. So it is very important for the users to be able to debug their containers at runtime. Problem is particularly compounded because of the geographical distribution of the edges. So we have written wrappers around existing Kubernetes logs and exec APIs. Logs and exec APIs that are tied to our notion of workload to provide a multi-tenant view for debugging containers. So any of our customer can just go to our core and debug their application, like even though the workload is geographically distributed, they can still see a single view of the application and debug it like any other cloud.
Do you do anything with triggering debug time windows, or otherwise figure out how you can limit the verbosity of logging that's flowing all the time, or?
No. So we have other pipelines to fetch the logs from the customer containers, but the debug is initiated by the user. So you enter a debug mode, and then we talk to all the edges to all the edges in scope for that workload to initiate the debug, and then you can just pick whichever location you want to debug and drop into a shell or view logs or do whatever you want.
But one of the questions I heard there, Preston, was, do we have a way to control verbosity of what's being logged across the estate in different modes? Not at this time. We've talked about that, kicking debug levels up and back, but we don't have.
Yeah, I mean, yeah.
We want that for our own services as well.
Yeah, we have that for our own services, but we are not exposing anything to end users as of yet. So yeah, these are some of the customizations we have done to Kubernetes to make it work for us at the edge. And yeah, so Rafay is the world's first CDN for microservices. We make your microservices run closer to end users.
Yep, and maybe this would have been a good place to have started, but we wanted to kind of jump into the technical content. And as we talked about just a moment ago, we're not a Kubernetes company in that sense. We're not offering Kubernetes as a service. What we're solving is application distribution of containerized microservices, right? So the Docker and containerized microservice format is has clearly dominated, and we think that's a great way to ship containers without carrying along the weight of virtual machines and so on. So and Kubernetes is a beautiful platform for orchestrating those microservices. It does a lot of things that we really like, and provides us shoulders of giants to stand on in that sense. Anytime we find a limitation, then we look for solutions within the technology that's provided out there. And when we don't find it, maybe it doesn't exist, or maybe we just didn't find it. But if we don't, we build what we need to customize the platform and meet what we perceive are the user needs. And we want to be plugged into the community, and that's a big reason for this presentation to this organization. And we really appreciate the feedback we get so that we can learn, because we certainly don't know everything, but we've kind of built a lot. We've jumped in. The team here is completely fearless and built something that's up and running. We've got some people kicking the tires, trying it out. If there are things that we've built that seem unique or useful to you, we'd love to talk.
Have you open sourced the things you're building?
We have not open sourced anything yet. We're a small team, and we have in the past, members of our engineering team have in the past worked in open source communities, and so we understand a few things about that and the cost. And I think at the appropriate time we will, because that benefits everyone. Even as a small team, if we can contribute some of the things that we've built and get them back from the upstream in future releases, that makes things better for us, as well as we can help contribute to the community.
I guess it'd be interesting to know if you have thought about this kind of balance between where things are potentially generically useful versus the ease you have found in using CRDs to simply kind of build the custom thing that you need to fit your needs. In other words, I think sometimes we are always looking for perfect reusability or perfect generalization, when the truth is there are enough specifics in some use cases that the lighter weight path is just to write something custom. And that's what's kind of beautiful about CRDs, is they do allow you to do that without necessarily everything having to be generic. But do you find that, this is a very kind of loose question, but like, where have you found that balance between trying to be reusable versus just addressing the need at hand? Like, do you have anything you've talked about today that you feel rises to the top as candidates to open source, or do you feel most of those were written pretty specific to your needs?
So if we look back, there's maybe some of the networking, piece, maybe.
Yeah,
but I'd love to get
the traffic thing, the traffic shaping we can.
Yeah.
Because there's no, I mean, so there's not a lot of development except for that one bandwidth plugin. There's not a lot of development.
Yeah, and to others running, multi workload or multi-tenant inside Kubernetes, this could be useful. It'll take a little investigation to understand how to plug it into the community. And Preston, if you have advice on how to best approach the Kubernetes community, or anyone on the call, but what's the best path in if we have something that we think is a good contribution? I don't even know the path, so.
Yeah, I think Haseeb made a comment about workload versus application. So I think the first part is sort of to do the compare and contrast with what the closest thing out there. Like, for example, in this case, what is the extension potential to the bandwidth plugin that's in CNI today as a CNI plugin? Is it an alternate plugin potentially, or is it a improvements to the existing plugin? You guys have more knobs you needed. But what would be nice is that way people who use the end annotations on pods for ingress and egress, if you have further control at the operator level of the cluster, that'd be interesting. But where you can kind of converge, where there's already some annotations being developed around CNI and pods for ingress and egress, then this would be interesting. But again, I think it sort of starts with a compare and contrast of the similar but not exact stuff that's out there.
I think of the requirement for larger than 1 byte config map. It's interesting as well, because that's a limit for etcd. If this is really a customer need, we can communicate with the community too.
Okay, great.
Yeah, I think that one's also really interesting. And I haven't really done a ton of hunting around for what else is out there. But like I said, I know that when we're looking at things like staging firmware updates, or any sort of staging of content, like lookup databases, or anything like that, is sort of it has some similarity to what CDNs must do as far as distributing content for staging locally, but in this case, it's not just for serving, it's for use by microservices running on the edge.
Sure, yeah, thanks.
Great.
Okay, if that's it, thank you. I think we should note that next week is KubeCon North America, and a number of us are going to be there. So if some people on this call weren't aware of that, I'd encourage you to go to the Edge IoT sessions, and maybe we'll try to get a informal face-to-face meeting going at some point.
Yeah, I don't think anyone from around the table here is going to be there, unfortunately, not this time. But appreciate it. All right. So again, if there are any further questions, anybody wants to kick the tires, you can reach out to us at eval@rafay.co. I'd be happy to continue the discussion. Thank you for your time. I don't know if there are any other agenda items for today, but we're happy to turn it over.
Yeah. So I don't have any other agenda discussions. Maybe just we can continue working around organizing about the KubeCon activities for the next week. So maybe we can just, leave it with the people who are interested into that topic.
Okay.
Okay. Bye. I'll hang on, but bye for the rest of you who aren't going to KubeCon.
Thanks.
I have a quick thing that's, I don't think needs to be part of a large group yet, if I can have 30 seconds.
Yeah, go.
Sure thing.
How tapped in is this group to the planned, not publicly discussed, but private, but not NDA and private, being privately discussed, the Linux Foundation's plan to organize all of the Edge projects under an umbrella? Is this group tapped into that at all?
It's news to me.
Yeah.
Okay.
Same here. Same here.
Yeah, I think it's so. Our Pete is driving it internally at LF, and as the rep of the Open Glossary of Edge Computing, I'm having a lot of those discussions because that sort of spans all of the Edge projects. But it's EdgeX Foundry, ONF, CNCF, at least part of it. I don't know what they're going to do with it. It's not all Edge related. Crano, and so on. And it's going to be a pretty big deal, I think. So this working group could play a pretty big role in how Kubernetes is messaged into that. I can ask our Pete if he would want to join one of these calls and give a 10-minute presentation. This is going to be probably late Q1, so it's nothing we need to rush on. But what's the group's appetite for engaging with that proactively? And I'm happy to liaison just as a matter of being involved in all these things tangentially anyway. But if this group wants to be more actively involved as a group, what's the appetite?
Is this umbrella just an umbrella of other Linux Foundation projects, or?
Yeah, so it's two things. It is primarily a umbrella of other Linux Foundation projects, but they're also introducing, and I don't know if they figured out how exactly it's going to work, but they're calling it an associate membership, and they're offering it to other sort of nonprofit open sourcey groups to join. So we've already talked to the TIA, Telecom Infrastructure Association, Infrastructure Masons, Open Fog Consortium, a bunch of those folks that I end up talking to because the Open Glossary is kind of the I spent a lot of sort of doing, quote unquote BD with that, with the other groups. But they're creating this associate membership that's free. And it doesn't give you any voting rights or anything, but it gives you a seat at the table and participate in all the activities.
Yeah, it's getting hard to keep up with the Linux Foundation. I got to say the number of projects getting announced.
It's astounding, and I've even heard rumors that they're looking at doing hardware too. So Jim's ambitions are impressive. Anyway, like I said, there's no rush. It's going to be probably late second quarter. I'm happy to bring the news back and forth, but if this group wants to participate, or individuals in this group want to participate more actively, just let me know and I can try to connect those dots.
Yeah, I guess I'm curious. In the short term, I wouldn't do anything different because of it, but yeah, if you can keep us informed, that'd be great.
Yeah, I think the primary opportunity is when the Linux Foundation goes to message around Edge. I think this working group, whatever it becomes, whether it stays a working group or becomes a project, and I'm not sure what the plans are, but I think it should be positioned very strongly and should influence the messaging. And that would be I think the primary point of intersection.
Yeah, I think in terms of something the Linux Foundation or this umbrella organization could do that would be useful is just providing a forum where people can link up with others, in these cross-cutting groups.
Yeah, because it's yes, it is very, very frothy and balkanized and
conference,
yeah.
even if it's online, because it really is rather difficult to keep track of all this. And I've been to conferences where you have people who really are focused on Edge IoT who come to KubeCon, and maybe at least half that conference really is of very little interest to them. So having something that approaches it from a use case perspective might be.
Yeah, that's a great idea. I imagine that's part of the plans, but I haven't talked to that level of specific. So I'll find out about that. That's a great idea, Steve. Okay, that's all I had.
Okay, thanks. I think some of us are still working on our presentation decks for KubeCon next week. So the rest of you, you're welcome to listen in if you want, but I think we're going to use the next 5 minutes maybe to talk about that. I unfortunately can't go over the top of the hour because I have a conflicting meeting, but I'd like to.
Maybe if we stay longer, you can join us later on.
Yeah. If it's still going an hour later, then I'll come back. Maybe I'll get out of my other meeting early, but I doubt it.
Yeah, I have to boogie as well. Thanks everybody, and have a nice weekend.
Take care.
So anyway,
Bye.
in that deep dive deck, just before I go, I did add a couple slides. One is just the speakers, and I cut and pasted people's icon right out of the KubeCon Sked site. But go obviously edit it, anything you don't like. Then I added one slide that I would view as kind of an intro overview. I'm unclear. I think that same presenter slide, by the way, could be used as a deck. We open the intro and the deep dive session, since it's the same speakers. And way down, I think it was slide 31, maybe 32, I added a slide I intended to be a close, where we're going to leave the audience with the links to get involved in the group. So I think it's good when you finally close, go to Q&A, to just leave that up, because it's convenient for people to snap a picture of.
Yeah, that sounds all good to me. Just one idea I had today about all the questions Cindy asked. So maybe we can split this into two presentations. So if the flow doesn't really fit with everything, maybe we just leave this presentation as we originally planned, with the workloads and a couple of deep dives in those workloads. And maybe Cindy can use like 10 minutes of the intro session to introduce Edge, and then we continue with the panel. What do you think about it?
My question is like, what for the deep dive? What's our goal in the end? I like the idea of introducing the workload.
I'll try to rejoin this just in case you guys are still at it in an hour. Bye.
We'll keep you posted on the Slack or where we are.
Okay.
And I don't know if you want to keep recording Dejan or not. I'm fine.
Yeah. Good point. Thanks for